Hello, good morning to all. My name is B. Ravi Babu, Department of ECE, SciTech, Puttur, and today we are going to see antennas virtual lab. So, which is very useful for antennas virtual lab, that is for an EC2. It is very easy to do the experiment of all antennas and to plot the graph in terms of radiation pattern, and also we will see the 3D picture. Okay, now let me give the demonstration of this software, how we can able to design the antenna, and thereafter we will run the program and it will show the result of radiation pattern. That we'll see one by one. Before going to do the experiment of these antennas, let's see manual first of all. So this is the first experiment of to study and plot the radiation pattern of simple dipole. Okay, by using this 4N EC2 software, we can do the experiment. And before, you may give the values of how to design the antenna. Okay, that is length of the dipole, and what is the lambda value, and the diameter, radius. All these values should be entered. Then only we can design the antenna, and thereafter finally we can run the program. Then based on that values, you will get radiation pattern like this. See this. See here. This is the radiation pattern. So which is shown as multiple colors. That is what radiation pattern 3D. Okay, and this is the actual radiation pattern. That is both left and right will be radiate energy. It looks like figure of 8. Okay, so this is the figure of 8. Now we will see all this radiation pattern once we enter the values of in that 4NEC2. We will see now one by one. Then this is the values which are going to enter in that software. So first we have to enter symbols, then geometry, then source, that is nothing but voltage, and then frequency. So based on these values we can enter in the software, and then finally we can run the program. Okay, let's see now. Now I'm going for software. This is for an EC2, and once it is open, you can able to click it for an EC2. It will be shown two desktops. Tabs, like this is the one of the basic picture, and this is the once we designing values, then it will be shown antennas. Okay, based on the values like microstrip antenna, simple dipole antenna, Yagwood antenna. What are the values we may entering these left side? Okay, thereafter you will design the antenna in this picture. Okay, let's see now. So now this is once it is clicking on the 4NEC2 software, it is available in the desktop. Then look at here, last tab. This is NEC edit. If you click it this one, it will show in this tab. Now it's already entered the values. It's a previous one. So that what I'm going to do, you are in new, right? So that you can go for file here. In this file, click it, new. Then it will show a new tab. Okay, now in that you should enter wire, what type of antenna which are going to use, that is wire. If you click it, default it will be shown wire. And next one is tag, that is 1. Okay, so based on the which I shown earlier, that is in the manual, okay, lab manual, based on that tab you can give the values. That is what first one is symbols. In that symbol, wire, and tag is 1. Then segment, that is 11. Okay, because we have a dipole in the sense positive pole and negative pole. Already we will discuss it in the lab, class itself. So you might know dipoles, one of the positive pole and negative pole. In that, in between, which are given as source, that is what supply voltage. So in that case totally 11 segment. Then x1 is 0. Let me show manual. See, lambda and then length dia. These are nothing but what symbols. Okay, in symbols you should write lambda, length, dia. So dia means diameter. So thereafter geometry. So type wire tag 1 segment 11 and then x1 y1 z1. So based on this order you can enter these values. For x1 in the sense that is 0, for y1 minus length by 2, for z1 0. Okay, accordingly here also x2 y2 z2. For x2 0, y2 positive length by 2. In previous, in place of y1, what is that? In place of y1, in between minus length by 2. Okay, that is the past one, negative poles. Then z2 is 0. Then diameter, radius, that is dia by 2. So like that, accordingly what are the values available in this manual, you can enter in the those values. Okay, let me share. Just a minute. Yeah, this is nothing but a geometry. So before going to symbols, first of all, then if you click it symbols, then click it here. Now you can enter lambda, lambda, lambda equal to 1. Okay, then again down, click it, it will show automatically 2. Then what is next one is length, length equal to again 1. Then after that below, click it once, then it will be dia, capital D IA small equal to 0.01. Okay, then after entering these values just click it here, it will show lambda equal to 1, length equal to 1 and dia equal to 0.01. After completing these values, then go for geometry. So already we have considered, that is wire and tag is 1, segment is 11 and then x1 is 0, x1 is 0 and y1, that is minus length by 2. By means slash. Okay, minus length by 2. Then z1 is 0. Then again x2 0. Then y2. So in place of y1 already we have entered minus length by 2. Now here in place of y2 positive length by 2. Hope you understand. Positive length slash 2. Now z2 equal to 0. Then radius, that is diameter, capital D small I A. Okay, by 2. So this is the value of geometry. Thereafter source, between positive pole and negative pole you may apply voltage. So here click it directly, in place of type here automatically default shown as voltage. Okay, right. Then tag is 1, tag 1, then segment 6. Okay, segment 6. Then here real, so let me take this manual. Geometry is completed. So source slash load is voltage, then tag 1, segment 6, real 1, imaginary 0 and margin 1. Okay, so based on these values you can enter. So real 1, real 1, imaginary 0 and margin 1, phase 0. Automatically it is default shown the values. Now directly goes to frequency. In that frequency, here, see here, frequency, that is you can enter 300 megahertz. Okay, 300 megahertz. Then ground automatically shown as free space. Okay, after that, once enter the values, see here directly last towards right side top, that will be shown as save. So what are the values you might be entered? Symbol, geometry, source, and then frequency. Come here and save it. Then finally towards the right side, next button, generate, that is run. If you show run, then it will be shown like this, different values. In that we have to select far field. If you select far field and directly, no need to change any other values, directly you have to select far field, then come to down, that is shown as generate. If you click generate, then based on your antenna designing, the radiation pattern shown like this. Okay, then in that radiation pattern, see here shows, then that shows you can select pattern. So this is your radiation pattern. Hope you understand. This is your radiation pattern, and far field you can select vertical like this, then both like this. So what are the things you have to select? According that it will be shown. Just a minute. Right. Okay. So based on that, now I want to see three-dimensional. So 3D. Okay. See here. Edit NEC na. Towards left side there is a 3D. Click it. If you click it 3D, then towards right side there is a structure. Below structure there is a, you can select anything like this. So this is your radiation pattern in terms of 3D. Then if you want to see multicolor like this. Hope you understand. This is your radiation pattern based on the simple dipole antenna. Okay. So if you have any doubts, please feel free to contact me in my comments, and you can also post a comment if any doubts regarding this software. Thank you.